Our esteemed speaker this evening, previously worked on quantitative teams at a whole variety of Wall Street investment firms. Please welcome the global head of sales engineering at KX Systems, Fintan Quill.
Can everybody hear me down the back?
Yep.
Yes, cool. So what I'm going to do today is I'm going to go through some slides, and then I'm going to do the two most dangerous words at like a conference session, which is live demo. So if any of you have your laptops, you can join me in the live demo. We'll, all die together. So if you go to the URL here at kx.com, and then if you go to the section software and then free version, you can actually just download it. And as I'm going through some of the slides, I'll be doing the demo a little bit later, but if you want to download it, it's very fast and very quick to install. And I've got two of my colleagues at the back here, Jamie and Aideen, who are waving their hands, and they've got their KX badge here. And they'll help you if you have any questions while I'm going through the speech. So they'll help you do the install. It's just a zip file you download and install it, and then you can get Q up and running. And we'll go through some very simple examples, but just to kind of get you up and running so everybody gets a little bit of a feel of what it's all about. But you can also just look at me doing a demo as well. It's not like, you'll still get a feel for it either way, so if you just want to have it downloaded, it's good. And if you go to the website, you have to give your email address to download it, and then you just choose the operating system. So you can give a fake email address if you want. Okay, so I am the global head of sales engineering at KX. So I've got quite a few slides to get through today, but hopefully I won't bore you too much. This is just a little bit about KX Systems, and this is going to be the most boring slide of the day. So we have offices in North America, Europe, and Asia. I'm based out of our New York office along with my colleague Abby here, Ian at the back in the dashing purple shirt, and Aideen and Jamie as well. We're majority owned by a company known as First Derivatives, who are based out of Northern Ireland. We have a very, very large user community. According to LinkedIn, there's about 4,000 plus people with KDB Plus and Q as a skill set. But obviously, take LinkedIn resumes with a pinch of salt. But we still do have quite a large community. And in terms of the industries that we're involved in, we're involved in the financial industry and the energy/utilities, pharmaceuticals, and software and telecommunications industry. We've really been born out of the financial services industry, and that goes back to the heritage of the company, and I'll discuss that a little bit later when I discuss the evolution of the Q language and the KDB Plus database. So, everybody knows about big data, and they want to shoot the next person who mentions the word big data. But when you're talking about databases and managing big data, there's a lot of different tools available nowadays. You've got your Hadoop style tools, your NewSQLs, your NoSQLs, your vector functional, your traditional relational database management systems. And so this was just taken recently from 451 Research from February of last year. So as you can see, it's a plethora of tools to download and try and install and play around with. So, what do you do when you try and look at something like this? It's very daunting for many people, like data scientists, database administrators, DevOps, etc. But we actually are here somewhere. So for those of you familiar with London, this is pretty similar to the London Underground map. And we're actually located in the part of London where Canary Wharf would be, which is kind of ironic given our financial services heritage. But as you see, there's a lot of different types of solutions. So what I'll try and do today is just explain the part of the diagram that we're on, even though I don't think we should probably be in that part per se. So basically, what are people talking about when they think about big data? It means a lot of different things to a lot of different people. Is it limited to in-memory? Is it limited to beyond memory? And what KX we're trying to do is we have been doing both streaming, real-time, and historical data for over 22 years now. So this has been part of our culture. But a lot of other systems nowadays, or previously, they do one of these three items. They're either just a streaming query engine, like a messaging engine, or they're just an in-memory data grid, or they're just a historical, data warehouse or something like that. So, that's what we try and answer, and that's what we try and show people. So our main flagship product is, as the questions and the answers have shown, is called KDB Plus. And it's an integrated columnar database and programming system. And as I say, we can do streaming, real-time, and historical data in the one platform using the one database and the one programming language. So it's a very, very powerful paradigm. It's not like a lot of other systems where maybe you have a SQL database for your back end and then maybe possibly like R, Python, or another statistical package for doing your analytics. We can do all of that with KDB Plus and Q language. And we come in both 32 and 64-bit formats. So the 32-bit format is the free version that you can download and play around with a little later. And then the 64-bit version is commercially licensed. So in terms of the functionality of the 32-bit version, the only limitation is that it's really limited to the 32-bit address space. So it means you can only load a maximum of 4 gigabytes of data into RAM. But other than that, the functionality of the Q language and all of the capabilities that are available are all there in both versions. So you're not really missing out on the feature set as such. It's just you're missing out on larger capacity essentially. So in terms of some of the features of KDB Plus, well, one of the main things is that we support standard operating systems. So we have builds for Linux, we have builds for Solaris, we have builds for Windows, and we have builds for OS X. And on Solaris, we have builds for both Intel and the Spark chips. And so I would say about 90 to 95% of our commercially licensed users are using standard Linux, and typically Red Hat Enterprise. And there are some compiler optimizations under the hood for Linux, so we usually recommend that. And we run on standard commodity hardware as well. So we've got versions that can run on, the Raspberry Pi all the way up to a massive supercomputer and everything in between. So it's a pure software solution. It's not an appliance or anything like that. You don't need to buy a massive machine or something like that. You can go and install it on your laptop. It's pure software. It's a very, very low footprint. The executable itself is a few hundred kilobytes in size, and the actual source code is quite similar in size as well. So what we're all about basically is in-database analytics. And you hear people talking about that more and more, but I think it's quite relevant, and it's quite relevant that I think we've been doing it for a reasonable amount of time now. It's a tried and trusted approach. And what I mean by that is basically you're bringing the analysis directly to the data. And where that helps is, with KDB Plus we have our data format, it could be on disk or it could be in memory. And we're doing the analysis directly on the data. So we're not shipping it back and forth between systems unnecessarily. So that helps in multiple viewpoints. It helps you have a more maintainable system because you just have one programming language, one database, so it's easier just to manage. It also helps from a performance perspective because it's just going to be faster because you're not copying data unnecessarily back and forth into other systems. And then it also helps from a hardware footprint perspective because once again, you're not copying data back and forth, so you don't need to double up or triple up on your memory. You're working directly on that data set and you're only using it. You're not doing any unnecessary copying back and forth. And so we also support compression as well, and we support compression from a few different viewpoints. And the first compression that we support is on-disk compression. So it means then if you've got, say, terabytes or petabytes worth of data, which many of our financial services and utilities customers would have, then you can just compress that. So it means, number one, you can save in terms of your hardware costs, because obviously if you've got petabytes worth of data, but if it's quite compressible, such as financial services tick data, you can maybe compress that down to maybe 10% or even less of its initial size. So that's a big win in terms of your hardware costs. And then secondly as well, if you're working off a very, very slow disk, it means you're theoretically just reading less data in off disk, and then you can do the decompression in memory. So it means then you actually just get better performance. And the second type of compression we support is IPC compression. So that means if you've got one queue process on one machine talking to another queue process on another machine, then you can compress that data as you send it over the wire, so you just get better performance. You get more bandwidth to play with. And then the third type of compression is using our WebSockets API. So we have various different interfaces, which I'll discuss in a little bit. But the WebSockets interface can now support the WebSocket standards, and it can support the WebSocket standard compression as well, which is extremely efficient. And because the nice thing about WebSockets is that it's a persistent connection as opposed to a lot of other TCP/IP connections. So it means you can maintain that connection throughout the day. And as you're sending data back and forth, and especially stuff like financial data, where a lot of the tokens are going to be the same, it means they can progress really, really well. And in some tests we've done, we've got like 100 to 200 times compression ratio as we get further into the day when we're sending this market data because it is a persistent connection. It just reads the tokens on the sender side and then sends it across. And then we also support parallelism as well. And we support parallelism from multiple different viewpoints. We do multi-threading, we do multi-processing, and we also do multi-server. So you can take advantage of all of the cores on your given machine, or you can take advantage of all of the machines on your grid. And in recent years, we've kind of moved more away from multi-threading and more towards multi-processing, just because we see it as more efficient. we can take advantage of your system much more faster. And also as well, you don't have any unnecessary locking or any unnecessary context switches. So if you just ship a task over to a process, it's much, much easier and much more efficient, and then you can just light up all of the cores on your machine until the Linux SA sees the lights dying in the server room. And then we also support multiple interfaces as well. So we pretty much have APIs available for most common programming languages. So as I mentioned, we have the WebSockets API, which is pretty nice if you're connecting to a HTML5 front end like JavaScript or Angular or D3 types of visuals running under the hood. We also support a C API, which can obviously support C++. And we have R, Python, Perl, Java, C, Sharp, C++, I mentioned that already, but most common programming languages. And you can see a list of those a little later. So it's all very powerful, and some of them work in different ways. Some of them simply just open up a TCP/IP socket connection, send the data back and forth to the database. And then also one capability of KDB Plus is that it can load shared objects into its own memory space. So then you can just take advantage if you have, say, a mathematical library written in something like C++, and you don't necessarily want to reinvent the wheel and write down the Q language. You can just load that into the same memory space as KDB Plus and just push the data into it, so then you've got no unnecessary TCP/IP hops. So it's just a much more lower latency solution.
Any REST interfaces is included?
Yeah, there is a REST, there are some REST interfaces available, and they're available on our GitHub page, which I'll mention a little later. So this is a typical sample architecture for a KDB Plus system. So it describes kind of this sort of Lambda architecture, which is the word they use a lot nowadays. So in this box here, you see our data coming in. So that could be streaming data, that could be coming from a market data feed handler, it could be coming from like a smartwatch, or it could be coming from a smart meter out in an electronic distribution grid or a water meter as well. And typically that data is coming in and is typically being parsed by a feed handler written in a compiled language like C or C++ or Java or something like that. But you could write those feed handlers within the Q language itself. And then what happens is this data gets pushed into the KDB Plus events engine. And in the financial world, this events engine is typically referred to as a ticker plant. But what this events engine is basically it's a distribution engine. So it takes the data and it distributes it to its downstream systems via a pub/sub protocol. And the pub/sub protocol is written directly into the Q language itself, so it comes out of box free of charge. And the first thing that will happen when the data comes into the events engine is it publishes its data down to a log file on disk. And typically you want to have this log file on a very, very fast, either SSD or a very, very fast local disk. You don't want to have it like in a very, very slow like NFS or SAN or NAS kind of thing. And the reason for that is that if any of your downstream in-memory processes go down for whatever reason, then you can just replay the data exceptionally fast from this log file. And the simplest example of a subscriber to the events engine would be the real-time database. And what that does is that basically subscribes to everything in the events engine. So it's basically just a firewall. It just gets every single event that comes in, and it just appends the data to its in-memory table. So in many ways, it's a bit of a dumb process. It just subscribes, gets the data, and just append it. But then you can have more complex what we call streaming query engines, or as it was known 10 years ago, CEP engines, complex event processing. The streaming query engines, what they do is they'll subscribe to a subset of the data. So say in financial markets, it could be I'm subscribing only for trading data and only for maybe like 5 or 6 ticker symbols in my portfolio. Or it could be I'm subscribing to smart meter data, but only within this region or postcode or something like that. And then what the streaming query engine will do is as the data is coming in from the events engine, it can run calculations on the fly as the data is coming in. So for financial markets, it could be a pricing engine, so it could be calculating something like the volume weighted average price. Or for smart meters, it could be like the average kilowatt hour usage per distribution. And so they're a little more computationally intensive because they do a little bit more calculations. But then what they do is they typically store it in very summarized in-memory tables, so they're much shorter. So then when you go and you access, say like the volume weighted average price or an average kilowatt hour, you're going to get pretty much instantaneous response from these small in-memory tables, as opposed to having to go to the real-time database and doing a full calculation every time you want to do it. So the real-time database then tends to be more for kind of like ad hoc querying. But then the streaming query engines are for very dedicated workloads that you want to get, you know, really instantaneous calculations. So you can imagine, like for financial services, you could have a high frequency trading strategy running in one of these streaming query engines and pushing the, you know, message back out to the market. And typically what happens then is at end of day or at any pre-configured interval, it could be end of week, or, you know, that's easily configured in the command line. But in most cases what happens is at end of day typically, the events engine sends a message down to all of its subscribers. And in the case of the real-time database, what it does is it basically pushes all of its contents down to disk, and it creates a new partition or new shard for that given day. And then what it does is it deletes all of its contents from its in-memory tables, and it's fresh again for the new day or the new week or whatever the pre-configured interval is. And so that means then, in the case of the real-time database, you get your hot data from today, so the data that you're probably most likely interested in, and then maybe your colder data will be out on disk in the historical database. So maybe data and queries that you're wanting, maybe you'll accept a little bit more latency on. But the nice thing about the KDB Plus historical database is it has the exact same inherent data structures as the real-time database. So when you actually query the historical database, it has the added advantage of being able to use the OS file cache, because KDB Plus has no library dependencies apart from glibc. So it means then it's all operating system calls under the hood, very, very lightweight. So it means then, say if you query yesterday's data from the historical database, and then you go back and you query it again, you'll typically get in-memory performance, because it's just going to cache it in memory, and you'll get really, really lightly fast performance. But then, if your cache gets filled, then underneath the hood, the operating system will just flush it back out to disk again. And it's all taken care of for you. You don't need to be aware of, oh, is this in memory, or am I going to blow up my memory space? The operating system will just take care of that for you, so it's really, really handy. So then I'm going to go back to outside of the database part, but just more into the language kind of part of things now. And as was mentioned in one of the questions earlier, KDB Plus and the Q language has evolved from a variety of different languages, and it really came from Ken Iverson when he came up with APL in 1962. It's this whole vector functional approach, and which is kind of becoming more and more popular these days, but it's taken over half a century to really, get its foot under the door. And of course, in 1979, Ken won the Turing Award for his paper called Notation as a Tool of Thought. And the URL for that is here, and I would highly, highly, highly recommend reading this. It really opens up your eyes in terms of how you can actually do calculations and literally the thought process in doing this. And then you go back to other languages and you're just like, I don't want to do that language again. So it's pretty cool. So Ken is an IBM fellow, and he was also a fellow at Harvard as well, I believe. And he was an exceptional gentleman. And then basically, one of the problems with APL was is that it had its own character set. So this is typically what an APL keyboard looked like, and there were rarely any of the actual alphabetical letters used. You had a lot of these like weird Greek characters were used. So it was all about making really dense code, so you could have a whole function or a whole statement or a whole program could even be just one line of code. So obviously that lent itself well in certain ways in terms of performance and optimization. And there are many, many APL systems still in use nowadays. And it's one of those things, because it's so little code, it just runs and it's easy to maintain. So it's just been running for years without anybody touching it. But obviously that became a little bit of an issue. So then came along Arthur Whitney, and of course he's got the typical Silicon Valley dress code of the black turtleneck. And Arthur Whitney is the KX co-founder and the president. So Arthur was basically, he met Ken, I think, when he was about 11 years old, in Canada. He's a fellow Canadian as well. They're both from, I think, the state of Alberta, or province of Alberta in Canada. And Arthur kind of, got taken under Ken's wing, and they became his protege. So then Arthur developed the A language and then the A+ language, of which I believe there's 1 million+ lines of A+ still lying around Morgan Stanley and still working to this very day. And he also wrote the first interpreter section for the J programming language, and I believe it was in one afternoon in Ken's country home. So it's well worth going to jsoftware.com and actually trying reading that and just thinking somebody wrote that in one afternoon. And it basically formed the basis then for a gentleman, Roger Huey, to actually implement that then after that, then Arthur invented the K language, and that's where he started off with KXC. He had the K language in 1993, and then that evolved, and then in 2003 he wrote KDB+. But he still has versions of K where he researches in, because he prefers the K notation rather than the more verbose Q notation. But the nice thing about K was he basically transferred a lot of Ken Iverson's ideas, but he did it with an ASCII keyboard, so it was a standard keyboard and not this very specialized keyboard, because that was the ASCII keyboard we're just taking over. So then, in terms of vector functional approach, this is his Sudoku solver. And this is the K language. So K is still quite terse, but as opposed to APL, it did use the standard ASCII character set. So you can actually run this and it actually does work. So this is a Sudoku solver. We think it's the shortest Sudoku solver in the world. So, it's pretty cool, but I'll leave it for another day for you to digest this. I think you'll have these slides afterwards, so you'll be able to see it anyway. But then came from that, then Q was the next kind of evolution of this. So as mentioned earlier, Q was built on top of K. So there was a version of K which was not commercialized called K4, and that was basically the bootstrap language for Q. But there were also optimizations written in ANSI C. So essentially the whole thing is really just written in standard ANSI C. There's no like crazy optimizations or anything like that under the hood. It's all standard ANSI C. And the reason for that was it would just be easier to be compliant with other operating systems. And so what is Q then? So Q has various different facets. First of all, it's a functional language. So you can actually write standard functions, execution. It's not, purely functional like a lot of other languages like Haskell, etc. But it still has a lot of functional ideas. You can create functions, and there's a lot of functions built into the Q language, and you can create your own functions and run them. It's also an array vector language, and we'll see that in a little bit as well. So the concept of loops kind of goes out the window. And there's a very interesting website called nsl.com, which is from a very interesting guy named Steve Apter. And the NSL literally means no stinking loops. Because he just was scared of just writing all of this for loops and while loops, etc. He wanted to write a function that would just execute over a whole vector or a matrix or array. And it's also a querying language as well. So the way the K language developed was it was a purely functional array language to begin with. And then there became a second language. Arthur decided that we can actually build a database out of this. So we created KSQL then, which is a SQL-like language. And then when KDB+ came around, he basically merged the K and the KSQL languages into one paradigm and came with the Q language. So this is where you get the functional, the array, and the query in one paradigm. And it's also an interpreted programming language, as we'll see a little later. We can just start coding straight at the command line, type out a query, we get a result back straight away, typically. And so it's very good for prototyping, doing quick prototyping, doing maintenance, debugging, testing, etc. And it's also a time series language, and it specializes in time series. And what I mean by that is comparing it to, say, a lot of SQL databases, where they typically only have maybe one or two temporal data types. And a lot of the time they even store them as strings under the hood, so you can't really do any meaningful analytics. Whereas KDB+ has many different temporal data types. So as mentioned earlier, we can store data down to nanosecond precision. We can store it to millisecond precision, to date, month, year, week, hour. And you can cast between these data types exceptionally fast. And because literally they're first-class citizens, not like an afterthought like a lot of other databases have done. And so this is really meaningful then when you're doing aggregations on time series data, which obviously is becoming more and more relevant as people are, capturing IoT-style data from sensor devices. It's very similar to what was done in the financial markets over the last 20+ years. You've got, your timestamp, your ticker symbol, and maybe your price, or else you could have your timestamp, your smart meter ID, and your kilowatt-hour usage. The schemas and the kind of the data model is quite similar, albeit maybe different cardinalities for different use cases, but fundamentally the data idea is the same. So this is a sample Q query. For those of you familiar with SQL, it's not really that much of a jump in terms of syntax. And what we're doing here is we're doing a simple aggregation. We're getting the open, high, and the low, and the close, which is a very typical financial services calculation. And so we define open as first price. And so the assignment operator in the Q language is just this colon. So this is similar to just doing select first price as open in SQL. Likewise, we've got high, which is the maximum price, low, which is the minimum price, and then close, which is the last price. So first, max, min, and last are all built-in functions into the Q language. And we have a lot more analytically rich functions built in as well, like moving average, moving sum, weighted average, weighted sum, matrix multiplication, matrix inversion. So there's a lot of those, analytical, statistical, and trigonometric functions, which are far more, inclusive than say SQL, where you can only do a small amount of analytics, and then you have to push it out into like a stored procedure or something like that. Whereas you've got a lot of rich analytics built directly into Q. And the other thing as well is the syntax here is slightly different. We have what we call a symbol or a varchar data type in Q, and it's denoted by this active character. And it's only on one side because we didn't want to put it on both sides because that would be an extra character for no reason. And so we also, so that's similar to doing like a single quote or a double quote in standard SQL. So it's just a slight syntactical notation, but it creates less code, so that's good. Okay, so then in terms of like comparing Q versus SQL, so Q supports vectors and column store. It's all about arrays, getting rid of loops and stuff like that. Whereas SQL then is kind of more traditional. It supports like rows and records, and so reading in a full record. Whereas KB Plus will only read in a column of interest, and you won't read in any other columns that aren't of interest. And because Q is a time series language, it basically supports order. Order is built in. Whereas SQL typically does not. You have to enforce order. Yeah?
How do you know when your varchar is over if you have a backtick only on one side?
And there's parts where basically take advantage of that. So if there's a space, it means you'll go on to the next statement. Or if you have a list of symbols, they will be separated. There won't even be white space.
So you can't have space characters in your varchar?
No. Well, you can, but you have to cast them from a string into a varchar.
Okay.
Yeah. I can show that a little later. So yeah, so SQL doesn't support order. You have to, force order on SQL. So as a result of that, I think it makes Q a lot more intuitive and concise, which in turn I think leads to like higher productivity and less maintenance. Because you've got less code, less maintenance, less bugs to fix. It typically makes systems run a lot easier.
Excuse me.
Yeah.
From my previous experience in financial services, I got folks doing high frequency related stuff. They always say, Q, K, they were saying they have a higher learning curve. And here you say more intuitive. How do you make them sound the same thing?
Yeah, so sometimes it depends kind of where you're coming from. A lot of the time if people are coming purely from SQL, it can be a bit of a learning curve because they're seeing something that's more analytically rich and a tighter syntax. But then we find that people that come from like mathematical backgrounds or like C or C++ or Fortran or Python or functional programming backgrounds, they tend to get it typically a little easier, but that's kind of changing. It's kind of changing as, functional programming languages are becoming a bit more sexier now in universities, whereas maybe 10 years ago, Java was being thrown in everyone's face. So I think that paradigm is slowly changing. There's certainly a learning curve, and we're not saying that there isn't. It's certainly not something that you're going to pick up like that. But I think after a while, and I think an example of this is actually, the intuitive nature of this is actually this query here. So this is the standard suppliers and parts database, which is like database 101. And this is the Q query, and then this is the equivalent SQL query. And as you can see, it's a lot less code. And basically what we do, because everything is ordered by definition in the Q database, when you do a group by and an order by, what we do is we just move that inside the select statement. And we have it select some quantity and by p.color from SP. So this is doing an aggregation, and it's also doing a foreign key join at the same time. Whereas you can compare that with what seems like it's loaded syntax in standard SQL, where you're referring to the two tables, you're referring to the color like 3 times, when it's like, well, typically when you're doing a group by and an order by, you almost always select that column as well. So why not just move it inside the select statement? It just makes it a lot easier, and then the grouping by and the ordering by will be much faster anyway, because it's a better functional approach. Yeah?
I have some questions on architecture sample architecture.
Yeah.
So sorry, I missed that. So your events engine, you said that it's a PubSub architecture.
Yeah. Yeah.
Okay. So means that does this PubSub architecture is supported by a web socket
So typically, the processes that I mentioned, those diagrams, they're all KV plus or Q
No,
processes.
but how do I send the data from my utility meter?
And so what you would typically do is, you would typically open a socket connection to say the events engine, and you would push the data in via that. So that's typically how it's done. Or the other way is what I mentioned earlier, where you can load it into the same memory space as a shared object.
Do you mean to say that I have to use all the utilities, my meters, and use TCP/IP connections?
And generally speaking, or else you can use shared objects as well. So you got both of those approaches. So if you want lower latency, you're probably going to want to use shared objects because then you don't have that TCP/IP.
But you know that most of the world utility meters support MQTT.
Yeah, that's right. I mean, that's one of these things that we'll probably look at as we get more and more into this space, because at the moment as well, I think there's like about 14 different protocols that are used. So it's kind of like, I think everybody's waiting to see that maybe these protocols will be whittled down to maybe one or two of the main ones that should be supported.
I have another question.
Sure.
So I have my own in-memory database.
Yeah.
So can I connect your KX?
Sure. Yeah, absolutely. We have ODBC and JDBC interfaces as well that are available, so you can easily get the data via Unix ODBC or any of the ODBC clients that are out there.
Okay. Do you have any special streaming language you have written on the KPLS for utilities and trading markets?
In terms of the
Like
streaming,
special data
I mean the
plans.
streaming query engines that I mentioned
Okay,
earlier.
I have the streaming from fixed protocol.
Okay, yeah, there are companies that develop tools that have like a fixed parser. There's a fixed message parser. We don't do that ourselves. We typically kind of concentrate on the main product itself, but there are many companies that have built, say, like fixed parsers for
So I
KV+.
can build the process on the top of it.
Exactly, yeah. And they're typically written, I think it's in C and C++. So, and our parent company, First Derivatives, they actually have fixed parsers available. And we just, at KX, so we've typically concentrated over the years into making the product as fast as possible. And we let other partners in our ecosystem build all of the connectors to the different APIs. Okay, so I'll go on to the next slide. So this is, as I mentioned earlier, we can do parallelization in Q, and we can do it very, very easily. Compared to like a lot of other languages, they typically have very clunky, very, very heavy multi-threading APIs. Whereas in KDB+, you just specify a command line flag -S for the number of slave threads or slave processes. So there's very, very little to do in KDB+ to set up multi-threading. And so this first line here, this is a function which is contained within these curly parentheses. And then we're doing this over each, and then we're passing in an 8-item vector. So what till8 does, which we'll see a little later, it basically creates a running sequence of 0 through 7, 0 through n-1. And then we're multiplying that by 1,000,000, and then we're passing that vector into this function here. So doing it single-threaded, we just do each. But then to do parallel, and to take advantage, say if we've got 8 cores on our machine, then we literally just change each to peach, and then that's your parallelization done. So you're not setting up threads yourself or doing anything like that. It's literally just adding a peak. And there you go, you got your multi-threaded interface right there, so you don't have to create, my new thread equals new thread and then all of that stuff. It seems easier to me. And I think typically you get quite linear scaling as well, especially if you run on very fast Intel chips nowadays, because you can have it run either multi-threading or multi-processing, like I said earlier, and you can avoid context switches very easily with the multi-processing. Okay. And then in terms of time series data then, as I mentioned earlier, we have the primitive temporal data type supported, so they come straight out of the box during the native executable. It's not like an add-on or an afterthought. And we have high precision timestamps, and then we can do very, very granular analytics on your time series data because we support nanosecond timestamp. And obviously, some of the clocks aren't quite at that resolution yet, but we're kind of ready. We have the data type there. Once those clocks are ready, and the operating system can support it. And these data types then are really, really good for doing temporal arithmetic. So if you want to add a day or subtract a day or take off 5 minutes or add 5 minutes or do windowing or bucketing and stuff like that, you can do that very easily. We also support bitemporal joins. And bitemporal joins is a concept that is missing from many, many database solutions out there. And what I mean by that is joining 2 different time series data sets. So the simplest example of that would be in financial markets where somebody says, I want to quote you this price for like Microsoft, it's going to be $100. But say that comes in at 10 o'clock for simplicity's sake. Obviously in reality you're talking about microsecond, nanosecond position here. But then what we do is then we say, okay, a minute later we're going to say, okay, we'll take that price. That's great. You know, we're going to buy Microsoft for $100 per share. And so, but then when you look at that database after the hood, your quote table is going to be at 10 a.m. Here is the quote price, and then at 10:01 here is our trade price. So in traditional SQL, when you try and join those two records afterwards to say, well, is my broker screwing me? What you do is you join that, but then your record is missing because you got two different timestamps. So what KDB Plus can do is it has the concept of a bitemporal join. It has two different bitemporal joins, and one of the bitemporal joins is called an as-of join, or AJ is the name of the function. And what it does is it takes our trade message at 10:01 and it looks into the quote table and it says, okay, what was my quote at 10:01? It says, okay, there's no quote at 10:01. So what it does is it looks back in time and it gets what we call the prevailing quote at that time. And there's also a second, more generalized version of this called a window join, where as an extra parameter you can specify a window of time before or after an event has occurred. So it means then you could say, well, I want to check out my latency in my high frequency trading system, or check if my broker is screwing me or not. And so you can say, okay, let's give me what happened 2 seconds before and 1 second after each trade. And for each of those windows, I want to get the maximum price, the minimum price, the average price. So I can really analyze both my latencies and both my price discovery or market impact. And that comes out of the box. They're just two simple functions, AJ and WJ, which is something that a lot of databases don't typically support. And then also, as I mentioned earlier, we can join time series on the fly. So in those streaming query engines, you can do these as-of joins or window joins. So if you've got your data coming in for, say, your own internal order and execution data, or then data coming in from the market, you can just join that literally in flight, record by record. Your data doesn't even need to be in a table when you join them. You can just join it record by record.
Can I split the data into clusters and join them?
Yeah, you can set them to clusters. So what a lot of people might do is for very fast feeds nowadays, like the options feed from the Chicago Stock Exchange, you're typically getting such high message rates there that at the feed handler level and even at the network level, they can't support those bursts of messages. They can be upwards of like 8 to 12 million messages per second. So typically what a lot of customers we've seen of ours will do is they'll split it out over symbols. So they'll capture symbols like A through M on host A and then M through Z on host B, and it's very, very simple to do, and then you can coalesce the data with calculations under the hood. So what we build what we call gateway processes, which can then join the data either between a real-time database and a historical database, or just databases on two different machines. And that, in the last few years, that's something we've worked on quite a lot. As previously, you could do that, but you had to kind of like write all the queue code to reach out and get the message from here, get the message from here, and join them. Whereas in the last few years, we've made that a lot more seamless, so you can really do kind of full-blown like MapReduce style semantics to take advantage of all of the machines and all of the processing cores and all of the disk I/O channels that you're best to call. So now what I'm going to do is I'm actually going to go into the demo. So this is a beautiful picture of me from earlier today. So, how many people have actually played with KDB Plus and Q before? Okay. How many have played with APL? Cool. And so what we'll do is, how many people have managed to download it and install it? Cool. So, let's go straight in here. So when you start off Q, if you're running it from Windows, you should have no major issues. If you're using it from Linux or Mac, typically what you want to do is install a tool called RLWrap, which is a line wrapping tool. It's just more convenient if you're like scrolling back up to the previous command and stuff like that. It will still work anyway, but it's just kind of a convenience tool, so you can get that with sudo apt-get or like macports install RLWrap. And so that, I've got that installed here, and it just makes a nicer prompt. So I literally type out Q, and then it brings up the Q prompt. And so now I can define a vector, X, and so this is similar to an array, so there's no crazy syntax. All I'm doing here is I'm just defining a vector of integers, 2, 5, space 5, space 7, space 4, space 5. So this is just a vector. This could be a vector of anything, a vector of prices or something like that. And so now that's saved down to X. So as we said, colon is the assignment operator. Now we type out X, we get the results back. Let's say this is the interpreted environment. And then we can start doing stuff. So as we saw earlier, KDB Plus and Q is a vector or array programming language. So if we do X by 10, it just automatically multiplies the whole vector by 10. So we don't have to write a for loop or any of that. That stuff goes out the window. And so there's a lot of functions that come out of the box in the Q language. So we can do count of x, and this just gives us the count of the items in our vector, which is 5 items. And then we can also do stuff like we want to get the sum of x. So what is the sum of all of the items in x? That gives us 23. But then sometimes you want to get the running sum, so then that's sums of x. So we just do sums of x, we get this vector back, and it's the running sum. I don't know if everybody can see it down at the back. Everybody see it down the back? And so then we can also do like a running product of x, PRDS of x. Because it's 2, 2 by 5, 2 by 5 by 7, 2 by 5 by 7 by 4, etc. So you can see you can build very, very powerful analytics very quickly in just a few characters. And you can also do things like distinct of x. So obviously in our original x we've got 5 is repeated twice, and this will just get the distinct value. And then what we can do is we can do AVG of x, the average, which is 4.6, or we can do a running average, AVGX of x, or we can do a moving average, so we can do 2 and AVG of x. So what that does is, to the left-hand side here, what we're specifying is the number of items that we want to calculate the average over. So if we look back at our original vector x, you can see what this is doing the first few values is just filling in no values, so we'll just fill 2 and 5. But then the third value will be the average of, which is 3.5, which will be the moving sum of 2 and 5, or the moving average of 2 and 5, the moving average of 5 and 7. So you see this window like this going on. And there's other functions like that. There's moving sum as well. We can do 2m sum x. Something like that. So there's a lot of these functions built in. There's weighted averages as well. And so what I'll do next, we'll start to build functions. So we can create a function very easily. So we can create a function f, and you just put the functions inside of a parentheses, curly parentheses, and we can do 2 plus 3 times x. So x will be our input parameter. And so we can do, say, f of 10, and that will do 2 plus 3 times 10. Likewise, we could call it in this what we call infix notation as well. So, if you're more familiar with that functional style approach, you can still use that functional style approach as well. And remember you saw earlier we had till 5, or till of 8. So what till does is it just creates a sequence from 0 to n minus 1. And so now what we can do.
You write to individual arrays?
Pardon?
Do you apply the functions you write to arrays?
Yeah, this is what I'll show now. So yeah, exactly. So now we can cascade all of this together. So now we could just do f of till of 5, and it will do exactly as you say. It will just apply it automatically to the arrays. So it's not just the inbuilt functions, your own custom functions will apply it automatically to arrays as well. Okay. And so there's other stuff as well. So there's a couple of gotchas you need to take care of. So you got 2 times 5 minus 3. Okay. There's a few puzzled faces in the crowd here. So, order of precedence in the Q language. There is none. Everything is just evaluated right to left. So what we're doing here is we're doing 5 minus 3, and then we're times 2. So there's literally no order of precedence. There's no, you don't have to think, oh, it's multiplication, bigger division, which is more important. You just do everything from right to left. And to enforce precedence, you can just put it in parentheses. So then if you just want the standard, this is what you get. And what this leads to is later on you can build very, very complex functions, and then you can cascade them together. And then it means you don't have to write very, complex code with a lot of parentheses. So actually after a while when you get used to this, it actually lends itself to really, really productive, nice and clean code with very, very few parentheses. So when we saw that function that we had earlier with the PowerPoint slide with the large function of sum of product of etc., if you wrote that in like standard programming languages, you would just have a plethora of parentheses, and the code would just be pretty much unreadable. So that's one pretty simple thing to do. And you can also create your own named parameters as well. So I can create a function tax, and I can explicitly name parameters by just putting them in square parentheses. So now I can do rate sale, and then I just do sale times 1 plus So now we're just explicitly naming these parameters, as opposed to previously we had KDB Plus can take 3 default parameters, X, Y, and Z, or unnamed parameters, but it can take upwards of 8 named parameters. Okay. So then we can do our tax then, and we can just do 7.5, and we can do 100, 200, 500. So now we can keep the rate constant at 7.5 and then pass in different sales. And then as you see, it will execute. But then say maybe we want to change the rates, then we can do say 7.5 for this one, 8.5 for this one, and 3.5 for this one. And there, we get these calculated across. So you can see you can create your own functions very, very easily. And what I'll do next is let's tie this together with kind of the tabular and the SQL style stuff. And so what I'll do is I'm going to create a vector called items, which is just going to be an array of symbols or a bar chart. And notice that I don't have any white space outputting this because white color got white space characters. And then we're going to have sales, which is just going to be a vector of integers. So we've got 6, 8, 0, and 3. And then we're going to have prices, which is going to be 10, 20, 15, 20. So now I've got 3 vectors, or 3 lists. And so what we want to do is we want to turn that into a table. So now we're going to create a table tab. And then we're going to, how we do that is we put in parentheses, and then we do square parentheses, and inside the square parentheses would go any key columns. But in this particular example, we're not going to put in any key columns. So then we just type in these 3 lists: items, sales, prices. And then just type out a tab. Voila, we've got a table for ourselves. So you can see then how we can tie these lists and vectors directly to the columns of the table. So now we can start coding. We can start doing we can start indexing into a table. So if we want to get the zeros row and the second row, so KDB Plus does 0 indexing. Then we just pull out those so we get the nut and the can. And likewise, we can just, if we want to get just the sales column, we do tab backtick sales. So you think of it as almost like key value. Think of it, the P being the column name, and then the value being the actual those column values. So you can do the P value extraction extremely simple. And then we can also join the table. So we can just join the table with itself. And the join function with two languages is just comma. Okay. So if we join the table onto itself, it's just one memory copy per column, and it's exceptionally fast. Obviously, I'm only doing it over small records here, but you apply this to like millions of records, it will be exceptionally fast as well. There's one mem copy per column. And so then we can do more SQL-like syntax. We can do select from tab where price greater than 12. Okay. Prices. There we go. And so here's a simple looking SQL statement. Obviously, some of you say, we usually do select star from tab when we select everything, but that will be an extra character. So I love it. So then we can do more complex, so select sales and prices, and then we can also define a column total, and then we can define that as sales times prices on tab. I'll get rid of the where clause. So as you see, if you're familiar with SQL, it's not the basic query kind of stuff. It's pretty simple. So now what happens here is the total column isn't actually saved out from the table, it's just returned, and then that's it. The table remains the same and hasn't been amended. Table looks exactly the same. And then say we could do something like cumulative total. And then that could be sums of sales times. Okay. So you see if we can take it back to that sums function where we get the running sum that we did earlier. So we get 60 equals 60 equals 0 equals 60. And you can see it adding up. So that can be really, really useful for a lot of different calculations. The simple one would be if you're doing order book management in the financial services sector. Yeah, question?
So what if a single element from a table without doing a select, can you like add 2, 4 or something?
Sorry, what was that?
If you want a single cell, a single element from a table without doing a select, can you do something easy like add 2, 4 or something?
You can't do that type of matrix style notation. What you could do is you could do tab sales and then index into that. So you would index by column and then you would index into that.
general like options for dealing with missing data.
Which, sorry?
For the missing data. Let's say
Oh.
some data not available.
Oh, okay, so if there's, you mean if there's like null values or something
Yeah,
like that?
right.
Okay, so we could, I could create a vector, which is a 1, 2, 3, and then 0 n is the null definition of the Q language. Okay, so this would be my vector. So there's two functions that are useful. I can use the fills function, FILLS, okay? And then that will just forward fill from the previous value. Or then there's also a function defined by this caret. So I could say for any null value, I'll just put in 100. So then I can do 100A. And then it just, so there's those two options. You got the fills, which will forward fill, or else you can just do this caret notation to fill the
Does that
default.
seem like a function effectively to those things?
You could do something like that as well. You could certainly, and then could just scan the whole table, scan the column, etc., etc. So what I want to show now is basically, I want to create a new function G, which is going to be my own custom function, and it's just going to do something stupid. It's literally just going to do add x plus y. Obviously, the plus operator is in the Q language already, but I'm just showing this for simplicity's sake. So I type out G, I get my the definition of my function back, but we've got our table tab. So what I'm going to do now is I'm going to just do select G, sales, prices from tab. So then you can see this is our own custom function that I'm applying directly to the table. So this could be an exceptionally complex function, and then you could just throw it straight into a query. So if you're, say, a KDB Plus developer, you could have somebody write a hell of a lot of libraries like machine learning algorithms, etc. You just get the function definition, and then you can plug it directly into your query. So this is where you really see the merging of the functional and the query style approach in one. And so what I'll do now is, and that's kind of like most of the demo that I'll do, so I'll go back to the PowerPoint and I'll just do a few closing slides. And what I want to do is I just want to go through a few resources so you get to know a little bit about the community at large. And so in terms of useful resources, we've got our developer wiki page, and that can be found at code.kx.com. And what I'll do is I'll put all of these useful URLs in the slides at the end that will be distributed to everybody. And so there's lots of different material here. There's beginning to end tutorials on the Q language and database management tutorials, and then there's a reference section which will describe all of the different functions in great detail that some of which we've touched on today, but there are many, many others like that AJ and WJ function. And then there's articles, and there's user contributed code, etc. as well, as it is utilities that are built on top of KDB Plus, and there's descriptions about each of the foreign language interfaces as well in great detail. And then we also have a community blogging site as well, which is just kxcommunity.com. So you'll see lots of different cool information. There's lots of user-contributed blogs from people who have written libraries, etc., and added them to the community. And then we also have two groups. So we have what's known as the K4 list box, which is for commercially licensed users, and that has about 1,200 people. And then we also have a Google group, which is for anybody. And that has a similar number nowadays. Actually, I think it's actually taking over from the list box in terms of the number of people. So you can just go on there, you post a question like, oh, I have this function that's running a little bit slow, how do you think I can make it faster? And typically you'll get an answer back from somebody within minutes. And if nobody responds, typically we at KX will go and we'll respond as well. We keep a keen eye on that too. So we encourage you to join that. There's lots of people involved, there's lots of interesting stuff, and you can go back and you can search all the different threads in the past, and you might see questions that you might have that have maybe been answered before. And then we also recently, just within the last few weeks, we started a GitHub page, which I think is kxsystems.github.io. And there's lots of contributed code there, some of it from KX, and also some of it from external companies, like people have built a hypergrid tool, different APIs, like there's several different Python APIs available now. You can just go to that page, and there's so many projects on there now. We only started it a few weeks ago, and we found that so many people have contributed code to GitHub for tools with KDB Plus, so it's really, really cool. And we encourage you to obviously any code that you write to contribute it to the GitHub page and let us know as well. And then there's also this book, which was just released a few weeks ago, Q-Tips. I've got it right here. And it's very interesting. It's written by a guy who's been working for hedge funds and investment banks in Asia. He's been using KDB Plus for about 10 years now. And it's very much an implementation guide, so he discusses some of the code examples, brings you through some code, but then he brings it to a real life scenario where he discusses like machine learning algorithms that you can apply to financial services or other industries as well. So it's very much an implementation guide. So it's not, you're just not just learning like the theory of it, you're really learning the pure application of it as well. And then there's also an interesting page, Stack Benchmark, which is Stack are the Securities Technology Analysis Center, and they do financial technology benchmarking. They're based just outside of Chicago. And what's pretty interesting is they run different benchmarking tests against a variety of different hardware platforms. So it could be running on like Intel chips or AMD chips with different network interconnects, different types of storage solutions like DRAM, SSD, NVDIMM, standard SAN, NAS, all sorts of different configurations. So it's really good to look at if you think, well, I've got an application and I want to see how it runs with these different hardware configurations. We've got all these benchmark figures available. You can download them and look at them. They're very, very detailed. And they're pretty cool if you're a bit more on the hardware side of things and the systems implementation side of things. And then, of course, there's the free 32-bit download, which is at kx.com. And then we also have KX community meetups. So if you go to kx.meetup.com, and we have meetup groups set up in over 55 cities worldwide now. New York is the biggest one, of course. We've got almost 300 people in our New York meetup. And we typically do a meetup once per month. And we get a lot of people who will build like tools on top of KDB Plus or an API, or they just describe an implementation that they've done or some sort of learning algorithm that they've done. And it's quite a vibrant community now, and we encourage you to sign up and come along to our meetups. And then also, we will be having a week of free workshops on June 1st through June 4th in New York here. And if you want to RSVP, you just go to email kxcommunity@kx.com with your name, your email address. Not obviously your email address will be there, but and then just ask to sign up. They're typically about 4 to 5 hours. They're very, very hands-on tutorials, some of which I've kind of gone through already. They're free of charge. We can provide breakfast and lunch. We encourage you to come along and try and learn it. Bring your laptops. You'll get down directly with Q and KDB Plus. And we've found that they've proven to be very, very popular. You get a little idea of like, you build a little financial ticker plant system, so you have a whole streaming query engine. You get to pop up several windows, and you just learn more about KDB Plus and the Q language, from a very, very high level. And that's it from me. Go to kx.com and follow us on Twitter @KXSystems.
Thank you very much. Thank you, Fintan as well. We're going to take questions, and 2 really good questions get these really good books. I am told they're like $50, by the way.
Yeah, you can get it on Amazon as well, or both in the Kindle format too, or paperbacks. Yeah.
Yes.
These days, most of the columnar databases, they are part of the Hadoop ecosystem.
Yeah.
Or they support XDFS installation. Do you guys provide that one, or it's not? Because you didn't mention that in your operating system.
No, we don't support HDFS, and we have run several tests on different distributed parallel file systems, such as like GlusterFS and Ceph and Fraunhofer. And we've done some of those benchmarks that I mentioned earlier, because typically they're just far nearer to native file system performance like XFS and ZFS and ext3 and 4. HDFS, it's getting better and better, but we still don't see it as fast enough. It really doesn't have good enough memmaps support yet, which is something that is like pretty fundamental to the speed of KDB Plus. In terms of Hadoop, we see it as good for like batch data load, but for really, really high performance stuff, we don't really see too many people using like Spark and Hadoop yet. Certainly not on the the financial services and the utility side we've been involved in. They've been more like kind of like the Facebooks of this world, where they've just got massively parallel jobs running huge amounts of hardware, whereas we're like really high performance, really, really fast stuff. So it's kind of getting there. I mean, there may well be something like that soon, but at this point in our roadmap, we don't envisage any support for HDFS quite yet. We see that the other parallel file systems are just better performance.
So do you say that this database KXDB is not like for massive database? It's just for small amount of?
Oh no, it'll be for huge data loads, but for really high performance data loads. So think it's got so much more of a smaller hardware footprint. So typically a lot of the time people ask us, oh, well, what about Hadoop, et cetera, but we typically say, well, you don't need to copy the data so many times. If you just get a reasonable size server, you know, we'll store it for performance because, you know, we're doing it all on one machine and it's such a low footprint. They typically don't need to copy this data back and forth. Or as I say, we can do the distributed processing as well, so you can have like a shared all or a shared nothing scenario to take advantage of that as well. So,
I don't think you said anything about indexes.
Okay.
Do you have a system that's different substantially for Oracle or?
Yeah, so we have the concept of what we call attributes, which are pretty similar to indexes. And there's 4 different types. We have a sorted attribute, a parted attribute, a unique attribute, and a grouped attribute. So they have optimizations under the hood. You know, we'll do a binary search if it's sorted, for example. So they're kind of similar, and you can add those. But typically, unlike a lot of SQL databases nowadays where they just index every column, we typically only have it on maybe 1 or 2 of the key columns that you're typically going to do a lot of your searches on. Say, for example, for financial data, you might have your data sorted by time and maybe grouped by symbol, or if it's on disk, you might have it parted by symbol, partitioned by symbol. And typically we find that works for almost all query patterns. Because then, the disadvantage of having so many indices, like a lot of SQL databases have, is you're doubling the size of your data set. So if most of the query patterns fit within, you know, 2 or 3 columns being pivoted on or grouped on or aggregated on, then you only need to do that, because what KDB Plus will do is it will do sequential disk seeks, and it will only pull in the columns that you care about. So if you've got a 100-column wide table, but you're doing an aggregation where you're only using 3 columns, KDB Plus will only do sequential disk seeks on the segments of those columns that you care about. So if a simple example could be if I'm doing like a volume weighted average price for Microsoft, what KDB Plus will do is for that given date partition or shard, it will reorder the data by symbol. So then when you go in to get your, say, your price and your symbol column and your size column for the volume weighted average price, you'll literally memory map those 3 columns, and you'll physically only read the segments of those columns that correspond to, say, like the Microsoft data or the symbol that you care about. So then you're just doing 3 quick sequential disk seeks. You read it into memory, and then you're executing it in memory, so you're getting really, really fast performance. So you compare that traditional RDBMS solutions, where you're pulling in the full, like 100 fields or something like that, and you're only using 3 of them, so you're just completely using your memory space, and then you're going to be swapping in and out, so you're going to be as fast as your disk, essentially. Whereas with KDB Plus, you're just going to be as fast as how fast your disk can read very small subsets of data sequentially, and then you can optimize hard drives, obviously, by doing read ahead and stuff like that, to, you know, getting better performance from your sequential disk seeks. Whereas you compare that as well, that SQL databases typically don't support order. So then your disk head, you just physically think about your disk head, it's going to be skipping all over the place, doing random accesses, whereas KDB Plus will pre-calculate exactly where it wants to go. Sequential disk seek for this column, sequential disk seek for this column, sequential disk seek. Your data's in memory, your query's executed, you're done.
Yes.
I mean, the Q language I'm not familiar with, but is there a way that you can help calculate very large metrics, like computation?
Yeah.
Like sparsing array, right? So I mean, if you put all elements in the memory, it's going to be memory bound. It's going to be large. So what is a better way that you can do a parallel processing of these very large metrics?
You could have it over several machines, or you could have it on the one machine and do the processing in parallel, and send it out over each different core, for example, or something like that. Or for stuff like sparse matrices, what you can do is you could have the data on disk and you could have it compressed, and you could just basically page fault the data in from disk on demand. So you can take real advantage of the way the disk is set up. And as I mentioned earlier as well, you could have read ahead set up, so that it knows exactly, well, we're probably going to be grabbing this much data after the next calculation, so it will already be faulted into memory when you get around to processing that part of the column.
In the Q language, is there any way to specify that, you know, this is like a sparse matrix? It's an easier way. They have like a row with a median, with a median element. In that case, mostly 0, but you want a certain element.
Yeah, there's no direct way to do something like that, but generally speaking, because it's a vector and array programming language, and all of the data is held contiguously, so just reading it in from disk isn't going to be too much of an issue. Yeah. And as I say, you could do stuff like compressing the data on disk, so you're reading much less data in on disk, because obviously if it's if there's tons of null data in your file on disk, you're going to get really good compression from that. So you're just page faulting a very small file in We do have some like short operators, but there's no like native box.
So the other question is how do the garbage collection work?
Also, yes, that's a good question actually. KDB Plus does have an inbuilt garbage collector. So the garbage collector works in multiple different ways. And it can work in immediate mode, where it will work kind of like Java, where the garbage collector will just kick in, or it can work in user prompted mode as well. So it means you could prompt the garbage collector to run at a specific point in time. So a simple example of that would be if you're in a trading room, and basically the last thing you want to do is at 9:30 when the market opens is have your garbage collector kick in, because then your trader will be ringing you up and you're going to get it. And so typically what you'll do is you can have a pre-configured inflows. You can have KDB Plus at the timer, the KDB Plus timer go in and say at maybe a quieter point of the day, then it can run the garbage collector. Or else, as I say, you could have it on in immediate mode as well, or you could not have the garbage collector on at all if you're really, really latency sensitive, but you have plenty of memory to take care of your problem. So it's very flexible like that.
We have time for just one more question.
Sliding hands. You want to
How does it compare to HP Vertica and Cassandra, and other use cases similar or?
Sure. So basically, one of the things that we like to point people towards is the SAP benchmarks. And because a lot of companies have tried to write benchmarks and have failed to write benchmarks. So we like to think that because the performance figures are out there, you can look at them. And, I mean, it's not necessarily always apples to apples comparison, because they can be run on different hardware setups, but generally we kind of encourage people to download it and try it yourself. I think you'll find the performance is a lot better. Without meaning to sound too brash.
Fintan will be here for one-on-one questions for everyone who didn't get a chance. Please feel free to come up. Thank you very much for coming. Thank you, Fintan Quill. Oh yeah, we got stickers here. Just come up, grab them.